Hi guys, these are your notes for section 9-7. We're going to talk about logarithms today that aren't the common log, that are of base 10, a base other than 10, excuse me. Is this the same one that we did yesterday? I don't remember. But here's a journal choice. I'm afraid that this might be a rerun, and if it is, then I'm sorry. Okay. This should make sense. Today we're going to talk about logarithms base other than 10. If you have a TI Inspire, you had this option all along. The people with the TI 84s could not look at logarithms other than the common log. But let's talk about this. The little number here does not have to be 10. We could have log base 2 of 8. And that's fine. Log base 2 of 8, that's how we will read it. They say the logarithm of 2 to the logarithm of 8 to the base 2, but I always say log base 2 of 8. They're used variables here instead of actual numbers. What would this equal? Well, this means, if it's x, 2 to the x equals 8. 2 to what power equals 8? That's going to be 3. Okay? Here is a chart that has different ways to write some of these. We're talking about base 3 logarithms here. Doesn't have to be base 3. It could be any base you want. Here is an example. They want us to rewrite this in logarithmic form. It's going to be log base what? Well, the base is what is the big number here. That becomes the little number when you write it in logarithmic form. So log base 7. 7 to the 4 goes over here. Because if you remember, it's 7 to the 4th equals 2401. Comes back around like this. So when you write it, it's log base 7 of 2401, and that equals 4. We're going to do lots of going back and forth today when we're writing from exponential to logarithmic form. This should be mostly new. All right, this one is a little different. They want us to write this equation in logarithmic form. What kind of equation is this? Well, the initial condition looks to be 12. This 0.359 tells me I'm dealing with an exponential decay problem. This doesn't look like y equals b to the x, though, and that's how I need it in exponential form to write it in logarithmic form. The problem is I have two numbers here. This is a b to the x. So what I can do is I can divide both sides by 12 first, and I have p over 12 equals 0.359 to the x. Now I should be able to write it in logarithmic form. It's going to be log base. What is the base? 0.359. That's okay. The base doesn't have to be a whole number. Equals, well, it goes 0.359 to the x, so the x goes over here, and in p over 12. I put in parentheses. That's kind of optional, although it is kind of a nice thing to do because you don't want this 12 to look like it's coming in with the base. Let's double check this. 0.359 to the x equals p over 12, and that's what I have. We are going to solve some logarithms with other bases than 10. If you have a TI Inspire, again, these are going to be very easy, but I do not want you to use your calculator today to solve these. I mean, I can't prohibit you from doing that. But the reason I don't want you to do that is because they really want you to practice with the definition today. Okay? This equals x. We don't know what it equals. So 2 to the x equals 16. Now, the only way we know how to solve this is by using the table. Going to your calculator, graphing y equals 2 to the x, and seeing where it is 16. That is the only way you know how to do this so far. That will work. People with the Inspires could use your calculator, but I just said do not use your calculator. And you always, always, always listen to me. So I know you wouldn't want to use your calculator. So what is the other option if I don't want to look at the table? Well, I can rewrite 16 with a base of 2. 2 to the x equals 2 to the, how else can I write 16? Well, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. This is a legal move because 16 and 2 to the fourth are equivalent values, so I can substitute there. So now I can see right away, what does x have to equal? X has to equal 4 for those two statements to be equal. Okay, let's look at B. This equals x. We don't know what it equals, so we're going to figure it out. Let's rewrite it as an exponential equation. 6 to the x equals the square root of 6. Can I rewrite this some way that has a base of 6? Yes. That is the same thing as 6 to the 1/2 power. So what does x have to equal? 1/2. Everything is getting tied together here. Last one. We don't know what it equals, so we'll say x. 3 to the x equals 1/81. Okay, this is a fraction. I need a base of 3 so that I can set these equal to each other. So 3 to the x equals 3 to what? Well, to get it to be in the denominator of a fraction, I would need a negative exponent. 3 to the second power is 9. 3 to the third power is 27. This is going to be negative 4. X equals negative 4. Okay, again, when you get these problems on your homework, I really want you to try to do it the way I just did, not by using your calculator. Now, what is that process called? In each one of those, what I did was I changed it to have a common base. That way, what we could technically do is we could cross out the bases and just say m equals n. Okay, this is called equating the exponent. So here, what I did, the 3's match up, so I'm left with x equals negative 4. That's called equating the exponents. When b doesn't equal 1 and b is positive, this is a valid process you can always use. Okay, here they want us to use a CAS to estimate log base 7 of 124. Log base 7, 124. So we're going to say it equals x. That becomes 7 to the x equals 124. And I cannot equate exponents here because I cannot change 124 to a base of 7. A good indicator was that it told me to estimate it to 5 decimal places. So what they want me to do is they actually want me to go to my CAS, graph y equals 7 to the x. I didn't want to do that. New page. I want to graph y equals 7 to the x. Alright, then they want you to go to my table. And where, I don't even remember what I'm looking for it to equal. 124, okay. I want it to equal 124. That's going to happen between 2 and 3. So I'm going to change my table to start at 2. Let's go by 0.1s. $124. It's going to be between 2.4 and 2.5. So I'll change it one more time. They want me to do this lots of times though. Oh crap. 2.4. Looking for 124. Okay, between 2.47 and 2.48. This process would continue. Okay, it's not fun at all. 5 decimal places is a ridiculous amount to ask you to go on that. And the answer ends up being, lucky for you, I have it right here. I have to turn the page. I know, the suspense is killing you. 2.47713. And then the B part asks for what exponential equation? We did that first. Okay, the one thing we need to know is the bases and these logarithms are inverses of each other. We are going to look at the graphs. Okay, if I have y equals 3 to the x, and I switch x and y, I have x equals 3 to the y, and I have 3, log base 3 of x equals y, because those two are equal. So this guy and this guy are inverses of each other. When we graph, we should expect some things. We should have a reflection over the line y equals x when you are looking at the graphs. This is not a square picture though. So we are going to look at this activity real quick. They want us to graph a value of b, and I'm going to choose my value of b to be, let's go with 2. So they want me to graph log base 2 of x. Some of you with your 84s cannot do this. So okay, I'm going to go, where is log? There it is, log, and I'm able to put a different base in. So I'm going base 2 of x. Here's the graph right here. Okay, the activity kind of wants us to fill out this chart. What is the domain, range, yada, yada, yada. Okay, so what was b? We picked b to be 2. What is the domain? What can x be? Well, look. Can I plug in negative values? No. The domain is going to be positive numbers. There is an asymptote coming through here. So my domain is going to be x greater than 0. You could say all positive real numbers if you want. Range is a little different. That's what y can be. And if you look, it goes up and down forever. So range is all real numbers. Do I have an x-intercept? Well, yes, I do have an x-intercept. It's happening right here at 1. The reason it's happening at 1 is because in this case the initial condition is 1, and it is the inverse of an exponential growth. There is no y-intercept because there is an asymptote. Where is the asymptote? At line x equals 0 or the y-axis. Okay, it is, if I was to graph y equals 2 to the x on the same, where is tab? Y equals 2 to the x, we should see a reflection over the line y equals x. Okay, they are inverses of each other. So here's what you need to know about this equation. We already kind of wrote it down, and this is all up for game on quizzes and tests. You need to know this information. You could always look at a graph though, just like we did, and you can get all this. It's not like you have to memorize it. Okay, here's our last thing. We're going to figure out what z is here. Find z if log base z of a equals 34. Yes, you can have a base that's a variable. We will just rewrite it as an exponential equation. Z to the 3/4 equals 8. You have solved problems like this. Chapter, I guess, maybe 8. We want to get z by itself, so I need z to be to the first power. How do I get z to the first power? I'm going to take both sides of the equation to the 4/3 power. 8 to the 4/3 is the same thing as the cube root of 8 to the 4th. I'm going to do the cube root of 8 first because that's 2. 2 to the 4th is 2 times 2 is 4, times 2 is 8, times 2 is 16. Z is going to be 16 here. Log base 16 of 8 should equal 3/4. You can check it out in your calculator if you need to. Okay, again, if you get stuck, you don't know what to do, write it in a form that looks more familiar to you, and it might make sense. Okay, lots of going back and forth between logarithms and exponential equations today. Here's your homework. Go ahead and jot it down so that you're ready to work when you get to class. Thanks.